చెప్పండి. హలో.
Okay, sir. Start it, sir.
Okay, right. Thank you. So, good morning, friends. Welcome back to our GATE lectures. It's 8 in the mathematics stream. So, we are discussing about solutions of ordinary differential equations. And in the last class, we have completed first order, first degree ordinary differential equations, linear equations, Bernoulli's equations, and exact equations also. And then we started higher order equations, linear differential equations with constant coefficients. As we discussed earlier, the standard form of the differential equation, like just once recap on those who were absent yesterday. This is a standard form of the differential equation that we consider dn by dxn plus k1 dn minus 1 by dxn minus 1 plus k2, so on and so forth. K and y is equal to q of x, where k1, k2, k3, so on and so forth, kn are constants. And then we use the notation dy by dx is equal to dy by dx, d square y by dx square is equal to d square y, so on and so forth. So the equation takes this form. So dn y by dxn is denoted by capital Dn. Okay. So the equation we write simply as fd of y is equal to q of x. So this is the structure that we go throughout this discussion. We will be using this fd of y is equal to q of x, which stands for the given differential equation like this. Right? This is what we do. Now, what is yesterday we have done seen complementary functions, how to find the complementary functions, and then complementary function is a solution of homogeneous equation. That means whenever q of x on the right hand side is 0, we call that equation is a complementary, homogeneous equation. The solution of the homogeneous equation is called complement function of the given differential equation. I repeat it. Whenever you consider f of dy is equal to q of x, if you consider q of x is equal to 0, okay, then that equation becomes f d of y is equal to 0. That equation is called homogeneous equation. The solution particular integrals for such problems. So in general, in examinations, that too in multiple choice questions, there are very few chances of asking very complicated functions on the right hand side, q of x. Mostly they will focus on exponential function, trigonometric functions, and some other basic functions. They cannot go for complicated function because the evaluation takes long time. So we will focus once again on the simple functions. So whenever q of x is equal to sin alpha x or cos alpha x, then yp is as usual 1 by f of d sin alpha x or cos alpha x. Why I am writing both is the method is same for both. So then we consider this as phi of d square. Then particular integral is 1 by phi of minus alpha square if phi of minus alpha square is not equal to 0. If it is equal to 0, that is a problem. Then yp is straight away you can take x by 2 alpha sin alpha x, or in general if you want to remember, for this one or this one, this is 1 by x into 1 by f dash d sin alpha x or cos alpha x. If you do a simple problem, d square plus 2y is equal to cos 2x. So complementary function will find. So but I have asked only yp, particular integral, that is given by 1 by d square plus 2 operate on cos 2x. Here alpha is 2. So replace d square by minus alpha square, that is minus 4. This is your answer. So when this f of minus square becomes 0, what happens? Let us see. So there is one more type of problem that we may come across. See here, the equation is d square plus 4d plus 4 operated on sin x. I replace alpha square is d square by minus alpha square is minus 1. So that becomes 1 by minus 1 plus 4d plus 4 sin x. This is what happens. Still the denominator d is existing. We have to do it till we don't have d here in denominator. So what I can do is d square is replaced by minus alpha square, but we don't have d square here. So as to get a d square here, what we do is multiply numerator and denominator with 4d minus 3. So this becomes 4d minus 3 by 16d square minus 1. Then you can replace d square by minus 1. This is what we get. So in the numerator we have 4d minus 3 sin x. D is derivative of function. So 4d means 4 into derivative of sin x, that is 4 cos x minus 3 sin x. That's how we do it. Sometimes what happens is the 1 by f of minus a square becomes 0. Then we have to apply this rule. I told you, no, this one. Next type of function is, yes, we have not done this yesterday. So phi of x is equal to x power k. So our formula is 1 by f of d x power k. We try to express this 1 by f of d as 1 by 1 plus r minus phi of d. And we expand 1 by 1 plus r minus phi of d in increasing powers of d. That means we write this 1 by 1 plus r minus phi d as 1 plus r minus phi d whole inverse. It need not be whole inverse always. Sometimes it power minus 2, power minus 3, so on and so forth, minus 4, so on and so forth. So we need to learn some basic formulae here, recollect. We don't say learn, we know all these formulae earlier we have studied, but anyhow, just let us recap these things. Useful formulae, 1 by 1 minus d. So say for example, phi of d is d only. So 1 by 1 minus d is 1 minus d whole inverse, that is 1 plus d square plus d cube plus so on so forth. This formula we require. 1 by 1 plus d is 1 plus d whole inverse. This is 1 minus d plus d square minus d cube, so on and so forth. The only change between the 1 by 1 minus d and 1 by 1 plus d is alternatively get positive and negative signs. If you remember this, you can easily get this. Similarly, 1 by 1 minus d power 2 or 1 minus d power minus 2 is 1 plus 2d plus 3d square plus 4d cube, so on and so forth. Similarly, 1 by 1 plus d whole square is 1 minus 2d, again very much similar, alternatively negative signs we get 3d square minus 4d cube, so on and so forth. These are the things, these four things are enough for us for our problems. So we use this. So solve this d square minus 3d minus 2 on y is equal to x square. So first when I said solve, we have to find complementary function also. Okay, so auxiliary equation becomes m cube minus 3m minus 2 is equal to 0. We have to find the roots to write the complementary function. Clearly, if you check, m is equal to 2 satisfies this equation. M is equal to 2 satisfies this equation because 2 cube 8 minus 6, that is 2 minus 2 0. So m is equal to 2 root. So then you synthetic division 2 1, the coefficients are 1 0, 0 is coefficient of d square minus 3 minus 2, 1 1 2 ones are 2, 2 2 2s are 4, 1 2 ones are 2. So the remaining polynomial is, if you take m minus 2 as a factor, the remaining polynomial is m square plus 2m plus 1. So m minus 2 into this m square plus 2m plus 1 can be expressed as m plus 1 whole square. So the factors are m is equal to minus 2. Sorry, the roots are m is equal to 2. I'm sorry, this m is equal to 2. Minus 1 and minus 1. So complementary function becomes c1 e power 2x. Okay, this becomes 2. c1 c2 plus c3x e power minus x. So this is complementary function. Coming to the particular integral, 1 by, as I said, 1 by f of d. So 1 by d square minus 3d minus 2 f of d operated on x square. Now as I said, now we express 1 by d cube minus 3d minus 2 in the form 1 by 1 plus or minus 5d such that powers of d increase. So 1 by d square minus, how do you write this? 1 by d square minus 3d minus 2 is, if we take minus 2 common, this becomes 1 minus d cube minus 3d by 2. So now this is exactly in this form, 1 plus or minus 5d. So this minus 1 by 2, 1 minus d square d cube minus 3d by 2. So we use this formula here. So when you use this formula, what happens? The powers of d gradually increase. So that is what we do. So this is minus 1 by 2, 1 minus d cube minus 3d whole inverse to x square minus 1 by 2. I apply the formula here. 1 plus d cube minus 3d by 2 plus d square to d square minus 3 whole square by 4 x square. See, here I stop the series here. I don't go beyond that. Why? Because the function is x square. What is the maximum derivative we can find? First derivative is 2x, second derivative is 2, third derivative is 0. There onwards, nothing is there. So, when you operate this here, d cube of x square becomes 0. D of x square, 2x. Here, what happens? If you see this next step, what happened? D cube into something. When d cube is there, the derivative becomes 0. You need not calculate that. So, you can stop the series here. So, now this is what we have. If you apply this operator on x square, first one x square, 1 by 2 into d cube of x square is 0, minus 3 into d is 2x. Okay. Here d square into d square minus 3 whole cube. If you expand this, become d power 4. Okay, d square d square. So only term that we get is 9d square. 9d square by 4 on x square. So d square x square is 2. So that becomes 9 by 2. So minus 1 by 2 minus 3x plus 9. This is the particular integral. Your solution now becomes yc this one plus yp. Find the particular integral of d cube minus 3d square minus 10d plus 24y is equal to x plus 3. So this is how we write this. I am not asking about the complementary function, I am asking only particular integral here. So as usual, I want to write it as a 1 plus or minus 5 of d. So take this 24 common, then this becomes 1 plus remaining term, take d common, d into d square minus 3d minus 10 by 24 x plus 3. So if you expand this, this is 1 plus 5 of d. So 1 by 24, 1 minus d into d square minus 3d minus 10 by 24. We don't go over the next term. By the next term we have d square. What is d square of x? 0. D square of 3 is 0. So no need to consider the next step. We stop there. So if you apply here now 1 by 24, 1 into x plus 3 minus 25 over d cube. This thing 0 minus 3 d square of this is 0. Only thing that we have is minus 10 d x plus 3. Okay. So 1 by 24 x plus 3 minus of minus plus 24. D of x is 1, D of 3 is 0. So this is what we get. This is yp of the given problem. Then we have, so we just go into the serious more tough things now. Equations of the form f dy is equal to qx when q of x is of the form e power ax into v of x. E power ax into product of two functions. Product of two functions. What is vx? Vx can be any function of x. So when it is multiplied with e power x, what happens to the particular integral? As usual, particular integral is defined by 1 by f of d. Okay, 1 by f of d e power ax vx. So the formula, we are not going into the details, theory and proof and all that, theorems and statements. Just we take the results. So how we write this is, we bring out this e power ax after shifting this d operator, differential operator by a. So the exponential function e power ax function wherever in differential equations and particular integrals, Laplace transforms and Fourier transforms. In almost all the problems, e power ax always shifts the variable argument. It shifts the argument. I think we have done Laplace transforms or shifting property. Exponential property always has that quality. It shifts the argument. So when you operate this first 1 by f of e power x comes out and it becomes 1 by f of d plus a operate on v of x. Okay. Now this our usual practice we do it. Now let us say find the particular integral of this d power 4 minus 1 operated on e power x cos x. So you can, for each of the problems I have asked only particular integral. For practice you calculate yp also. You calculate yp also. Sorry. You calculate yp also. So the by complementary function. What I mean is complementary function. How we get d power 4 minus y is equal to the homogeneous equation. The auxiliary equation becomes m power 4 minus 1 is equal to 0. This you can write it as m square minus 1 into m square plus 1 is equal to 0. M is equal to plus or minus 1, or m square is equal to plus, m square plus 1 is equal to 0 means m is equal to plus or minus I. So you get 4 roots plus or minus 1 and plus or minus I. So particular integral 1 by d power 4 minus 1 operate on e power x cos x. So as I said, e power x shifts the argument by d plus a. So replace d by d plus a and bring out e power x out of the operation. So e power x comes out 1 by d plus 1 whole power 4 minus 1 operate on cos x. This is what we mean by this. This is how we apply this formula here. So e power x is there 1 by d plus 1 whole square plus 1, d plus 1 whole square minus 1. This is like that, a plus b into a minus 1. So this is d square plus 2d plus 2. So d square plus 2d plus 1 minus 1 gets cancelled. This is what we have, it's cos x. So whenever cos x is there, what we do? Replace d square by minus a square. What is a here? 1. So minus a square is minus 1. So replace d square by minus 1. So this becomes 2d plus 2 minus 1. That is 2d plus 1. And this becomes 2d minus 1. So 1 by 2d plus 1 into 2d minus 1 cos x is the same as e power x 1 by 4d square minus 1 operated on cos x. This is e power x cos x by replace d square by minus 1. That becomes minus 5. So this is your particular integral for the given problem e power x, given function e power x cos x for this differential equation. In the problem, particular integral of d square plus 2d minus 3 operated on y is equal to x square e power minus x. So complementary function d square plus 2d minus 3, the factors are d plus 3 into d minus 1, d plus 3 into d minus 1. So d plus d is equal to minus 3 and m is equal to minus 3 and m is equal to 1. So e power c1 e power minus 3x plus c2 e power x will be a complementary function for this problem. And if you are asked to find the complete solution, you need to calculate complementary function also. So then partial integral becomes 1 by d square plus 2d minus 3 operated on x square e power minus 3x. Okay, this is what we get. This is d plus 3 into d minus 1. So e power minus 3x, if you take it out, it shifts this d by a. So a is minus 3. So 1 by d minus 3 plus 3, d minus 3 minus 1. So this becomes e power minus 3x by d into d minus 4. Okay. So 1 by d is x cube by 3. So operate on 1 by d minus 4. So again I want this in terms of 1 plus r minus 5 of d. So I take this minus 4 out. This becomes 1 minus d by 4. So if you transform it, when you apply this on x cube, we get up to d cube term. We have to consider this in the expansion. What is d power 4 of x cube? 4th derivative becomes 0. So we need not consider terms beyond d cube. D power 4 of x cube becomes 0. Similarly, d power 5. So we need not consider. I stop the series with d cube only. So x cube plus dx cube is 3x squared by 4 plus 6x by 16 plus 6 by 64. This is your particular integral. Then case 5 is x power m into vx. X power m into vx. In this case, particular integral is, we have a big formula. That's why I said generally in this type of problems we will be coming across only simple problems like e power x, sin x, cos x, maybe e power x into x, e power x into sin x. Simple terms. So in an objective question, multiple choice questions, these things is very difficult to answer, but in the course I have to teach these things. But in the examinations, I suppose no one dares to give in general. So 1 by f of d operated on x of vx is, mind you, I am not using x power m here, only I am using x only, because x power m becomes very difficult. Simply start with x first, then again x square you can do it. So that is x minus 1 by f of d, f dash d, 1 by f of d, v of x. The order, see the order. In this way we apply this. So what is the particular integral of d square plus 2d plus 1 operated on y is equal to x cos x. So it is 1 by d square plus 2d plus 1 x cos x, because x into vx form is there. So I apply this x minus 1 by f of d is 1 by d square plus dd plus 1. F dash d is 2d plus 2, 2 into d plus 1. The 1 by f of d, 1 by d square plus 2d plus 1 operated on cos x. I'm applying this formula here. I repeat, x minus 1 by f of d, 1 by d square plus 2d plus 1. F dash d is 2d plus 2. That means I take 2 out, 2 into d plus 1. 1 by f of d again, cos x. So x minus 1 by d square plus 2d plus 1, 2 into d plus 1. So here first up you complete this, replace d square by minus 1. So because all a is 1 here, minus 1. So d square is replaced by minus 1. So minus 1 plus 1 cancels, 1 by 2d. So 1 by 2d, here also you can do simultaneously x minus 2y, d square plus 2d plus 1 is d plus 1 whole square, and this is 2 into d plus 1. So d plus 1, d plus 1 can be cancelled here. And here what happens? 1 by 2d cos x. So 1 by 2d and 1 by d is, if d is differential operator, 1 by d is integral operator. So 1 by d cos x is sin x. So this is sin x by 2. So this 1 d plus 1 is cancelled. So from this we can write this as, you take this 1 by 2 here, x minus 2 by d plus 1 sin x is what we have. This is 1 by 2 x sin x minus 2 by d plus 1 into sin x. So whenever you have d term in the denominator, and operate on sin x or cos x. What I do, the simplest thing is multiply and divide by d minus 1. So 1 by x sin x. D minus 1 by d square minus 1 sin x. So 1 by x sin x. D of sin x is cos x minus 1 sin x. The denominator, what happens? D square minus 1. Replace d square by minus 1. So it becomes minus 2. So the answer is 1 by 2 x sin x. If you take minus of minus plus, cos x minus sin x by 2. So this is how we deal with problems like this, x power m into p of x. When p of x is any other function of x. See, we have considered exponential functions, trigonometric functions, polynomial functions, e power ax into vx, then x into vx. Is it all over? No. You can have, sometimes we come across some functions for which we don't have formula. Okay, come complicated function, maybe some typical problem, logarithmic function. So for example, you have secant function, you have tan function, cot function, cosecant function. We have defined for sin x, cos x. We have defined for exponential function. We have not defined for tan x. We have not defined for cos x. We have not defined for logarithmic function. So whenever this qx is any other function of x, then how to find the particular integral? So in this case, your particular integral becomes 1 by f of d q of x as usual, and then what we do is we split this f of d into factors. So f of d is d minus m1 into d minus m2 into so on and so forth, d minus m1. So and then, so 1 by f of d becomes 1 by d minus m1 into d minus m2 and so on for d minus m1, mn. Then split this 1 by f of d into partial fractions like this. a1 by d minus m1 q of x, a2 by d minus m2 q of x, plus so on and so forth, an by d minus mn q of x. The advantage here is, once you apply this, we have know that 1 by d minus a of qx is equal to e power ax into qx e power minus ax. This is the first formula that we have studied in particular integrals. So then, for each of these things, each of these fractions, we have to apply this formula. So this one, apply this formula. For this one, apply this formula. For this one, all n terms. How many factors do we have? For all those functions, we have to apply this 1 by d minus a partial fractions. So we get the complete solution. So for example, you consider y double dash plus a square y is equal to secant ax. So here the auxiliary equation is m square plus a square is equal to 0. The roots are m is equal to plus or minus ai. So complementary function is c1 cos ax plus c2 sin ax. So particular integral is 1 by d square plus a square secant ax. You can split this because a plus by ai and minus a are the roots. You can write 1 by d square plus a square as 1 by 2ai 1 minus 1 by d minus ai minus 1 by d plus ai operated on secant ax. Now consider the first integral 1 by d minus ai operated on secant ax. Okay. Now we apply this formula. So this is e power, in case of a you have ai. So e power iax, c integral of secant ax e power minus iax dx. So e power iax secant ax e power minus iax is cos ax minus I sin ax secant ax 1 by cos ax. So if you simplify this, cos ax cancel 1 and minus I sin ax by cos ax is I tan ax dx. So integral of this e power iax, integral 1 is x, minus tan ax is log secant ax, or minus tan x integral is log cos ax by a. So this is what we get. So this is 1 by d minus a, and the other term is 1 by d plus a. What is the difference between d minus ai and d plus ai? Only difference is plus I minus I. Plus I and minus I. So in this, if you replace plus A by minus plus I by minus I here in this, replace I by minus I, then this becomes 1 by D plus AI. So this is a nice tool when we have complex functions, imaginary parts. Simply you need not do both the integrals. Replace I by minus A. Things will be very simple. So when you replace I by minus I, they are called complex conjugates. Complex conjugates. When you replace I by minus I, this becomes 1 by D plus AI secant kx. So this becomes e power minus IAX x minus I by A log cos AX. So the white we use now, this is what we have. Okay. You substitute both the things there. Y2 becomes 1 by 2ai e power IAX x plus I by log cos AX minus e power minus AX x minus I by A log cos AX. This is the term that we get. So it takes similar terms x by A e power IAX minus e power minus IAX by 2i. So this term and this term we have taken out, and the other terms a square into 2a into 2a 1 by a square log cos AX again e power IX minus e power minus IX. I cancels here. See what happens is I cancels here, IA cancel, II cancel. So 1 by a square we have taken out, 1 by 2 we have taken inside. So this is again you can express as sine functions. Okay, sine function, cosine functions. That's how we get the particular integral. This thing. But thing is, in one way it is simple, one way is useful, one way it is complicated. When the question is asked as a multiple choice question, yes, I do accept this is somewhat too large for a 1 mark or 2 mark question. Another general method that we have is method of variation of parameters. This is a very powerful method. Very powerful method. This method is applicable to equations of the form y double dash plus p of x y dash plus q of y is equal to v of x. See, though this method of variation of parameters is defined for variable differential equations with variable coefficient, that means p of x and q of x are variables, functions of x, but still in practice at our graduate level we apply this method only for equations with constant coefficients. We restrict our discussion to differential equation with constant coefficients. The procedure goes like this. If y1 and y2 are two linearly independent solutions, why I said two linearly independent is because it's second order equation. Because it's second order equations, I need only two linearly independent solutions are enough for me. So if y1 and y2 are two linearly independent solutions of y double dash plus py dash plus py is equal to 0, then particular integral is minus y1 integral y2 vx by, vx is this one, by w plus y2 integral y1 into v of x by w dx. So then what is w here? Only term that we don't observe here, we have studied is w. This is w is a very strong statement. This is called a very popular name. This is Wronskian. This is called Wronskian. W is Wronskian is defined as w is equal to y1 by 2. The first row is y1 by 2. The second row is y1 dash y2 dash. So determinant of this is called Wronskian of y1 and y2. So when y1 and y2 are linearly independent as said here, then this Wronskian is not equal to 0. That's why you can ask me why denominator is for w is there in denominator. What happens if w is equal to 0? When w becomes 0, your particular integral does not exist. Then what is my guarantee? Because I said y1 and y2 are linearly independent, Wronskian is never 0 because of this property. Remember, recollect, we use this concept in Jacobians while discussing partial differentiation. Jacobians functional dependence we have studied. Two functions f of x and gx are said to be functionally dependent if their Jacobian is not equal to 0. We have studied this already. So we are using in differential equations, we don't call it as Jacobian, it is called Wronskian. So the difference between Jacobian and Wronskian is Jacobians, the functions can be anything there. But in Wronskian, what happens? Y1, y2 have the common property. What is the common property? They are linearly independent solutions of y double dash plus py dash plus qy is equal to 0. But in Jacobians, we are not discussing any differential equations, and we are not saying that f and g satisfies any differential equations. That they need not be solutions of any differential equation. You can take any two functions. But in Wronskian, what happens? Y1, y2 are linearly independent solutions of a given differential equation. Then Wronskian is different from 0, and the particular integral is defined by so on and so forth. Okay. Next thing is, now do some problems on this. Y double dash plus 4y is equal to tan 2x. Y double dash plus 4y is equal to tan 2x. Complementary function. Consider auxiliary equation. M square plus 4 is equal to 0. Question now in this, yes, I'm sorry, I'm coming back again. Y1 and y2 are linearly independent solutions of this thing. Then particular degree is expressed in terms of y1 and y2. And the Wronskian is this is all good, very nice. Then who will give you y1, y2? Who will give you y1, y2? So y1, y2 are obtained from the complementary function. You know that complementary function, while c1, y1 plus c2, e2, c1, y1 plus c2, y2 plus c3, y3, we are writing the complementary function. There we say that y1, y2 are linearly independent solutions. Those functions we consider. So m square plus 4 is equal to 0 is a complementary function. So the auxiliary equation, we solve it, m is equal to plus or minus 2i. So complementary function becomes c1 cos 2x plus c2 sin 2x. So y1 you consider this as cos 2x and y2 as sin 2x. Then your Wronskian becomes, the first row is y1 by 2 cos 2x sin 2x, and second row is derivatives. Cos 2x derivative is minus 2 sin 2x, and the derivative of sin 2x is 2 cos 2x. Then if you consider the determinant of this, cos 2x into 2 cos 2x, 2 cos square 2x, minus of minus plus 2 sin square 2x is 2, which is not equal to 0. Okay, so your particular integral becomes now, using the formula, minus y1 into y2 tan 2x by Wronskian plus y2 into integral y1 into tan 2x by Wronskian. So y1 is cos 2x, so I put it here, minus cos 2x integral y1 is, y2 is sin 2x into this function is tan 2x by Wronskian 2 plus y2 is sin 2x into y1 cos 2x tan 2x by 2dx. So take this 2 out, minus cos 2x by 2 integral. This tan 2x is sin 2x tan 2x, you can write it as secant 2x minus cos 2x dx. So sin 2x by 2 into, here tan 2x is sin 2x by cos 2x will be cancelled, gets cancelled. So integral of sin 2x, that is minus cos 2x by 2. So this integral becomes log secant 2x plus tan 2x. So this is how we get this evaluation of the integral. So this is your final answer. So another example, y double dash minus 2y dash plus y is equal to e power x log x. So again the complementary function is, the equation is m square minus 2m plus 1, that is means m minus 1 whole square, m is equal to 1 and 1 are the roots. So complementary function becomes c1x plus c2 into e power x, because we have repeated roots. So then you take yn as c2 e power x, y2 is x into e power x, you take that as y2. clearly they are independent functions. You can check by Jacobian or maybe by Wronskian, you can check if they is not equal to 0. So Wronskian becomes e power x, y2 is x e power x, and second row is the derivative, e power x derivative is e power x e power x derivative is e power x into derivative of x is 1, then x into e power x. This is derivative. So e power 2x, if you consider this Wronskian, e power 2x into x plus 1 minus e power 2x into x. So if you take e power 2x common, x plus 1 minus x plus 1 minus x. So if you minus x and minus x get cancelled, then become e power 2x. So use this Wronskian to find the particular integral, that is equal to minus y1 integral y2, that is x e power x into given function e power x log x by Wronskian e power 2x plus y2 into integral y1, that is e power x into the function e power x log x, okay, into y2 x e power x by Wronskian e power 2x. So here e power x into e power x is 2x, e power 2x, e power 2x gets cancelled. Here also the same thing, e power x into e power x is e power 2x gets cancelled. So what is remaining is minus e power x integral x log x dx plus x e power x integral log x dx. So you apply UV rule here, plot rule here. So you minus e power x into x square by 2 log x. You take the integral function and differentiable function here minus x square by 2 log x integral derivative 1 by x dx. Similarly, x e power x into log x minus integral x into log x derivative is 1 by x dx. So this becomes x square by 2 log x minus integral x by 2, or if you integrate that again, x square by 4 plus x e power x into x log x minus x gets cancelled, 1, integral of 1 is x. So this is wrong expression, which is the particular integral of the given problem. So that's why I said, when given this, when these problems are given as MCQs, set of problem, you unfortunately these questions are given, be very careful, do it carefully, or otherwise one more alternative for this is, if you can do it, the alternatives, you find a y double dash y and substitute here, whichever satisfies the equation, that will be your solution. There is a shortcut, one way shortcut, okay. I don't say you get exactly the same thing, maybe there's a shortcut. So till now we have considered equations with linear, constant coefficients. Sometimes a particular types of differential equations that are there with variable coefficients, but can be converted into constant coefficients. Constant coefficients equation. There are two such forms of linear differential equations with variable coefficients, which can be converted into linear differential equations with constant coefficients of the form f of dy is equal to q of x. So the first one is Cauchy's linear equation. So it is of the form x power n dn by dxn plus k1 into x power n minus 1 dn minus 1 by dxn minus 1. So see the coefficient here, x power n. Here it is x power n minus 1 till now. Earlier differential equation we didn't have this x power n minus 1, only we had only k1, k2, so on and so forth. Here we are having x power n minus 1. Gradually they are decreasing, xn, x power n minus 1. So these are called variable coefficients. So Cauchy's linear equations are the form. What is the structure of Cauchy is, when you have nth derivative, then by x power n. X square d square by dx square, x dy by dx, x cube d cube by dx cube, like this. So such a structure is called Cauchy's structure. And to solve such problems, let x is equal to e power t. So question now is how we convert this thing here. Is it necessary for us? Yes, necessary. Sometimes a theoretical question may be asked on this. Which of the following functions converts the Cauchy's linear equation into equations with constant coefficients? x is equal to e power t, x is equal to log t, x is equal to 1, x is equal to e power minus t. Okay, when this is so important that even that can be asked as a theory question in multiple choice answers. So don't neglect these intricate points. Follow them very closely, learn them very closely. Sometimes you may get it directly. So when x is equal to e power t, we know that t becomes log x, and call d as d by dt. d by dt. But in the problem it is dy by dx. Let us call d as d by dt. So observe the difference between these two. So what happens, dy by dx now is dy by dt. Why dy by dt? Which because y is a function of x, y is a function of x, but x is a function of t. Y is a function of x, x is a function of t. Then we are using chain rule. We have discussed in ordinary derivatives and the partial derivatives. We apply chain rule. Y is a function of x and x is a function of t. So dy by dx becomes dy by dt into dt by dx. So dy by dt is capital D of y and dt by dx is t is log x. So what is dt by dx? 1 by x. Okay. So 1 by x dy is equal to dy by dx. So if you send this x to the other side, what happens? X dy by dx is equal to dy. So the term here x dy by dx now a variable coefficient term with variable coefficient, that is now converted into only dy. You don't have a variable here, it's a constant. That is the advantage. Similarly, d square by dx square is dy by dx of 1 by x dy by dt, dy by dt as I said. So minus 1 by x square into dy by dt, applying u into v form of product rule, 1 minus 1 by x square into dy by dt plus 1 by x into dy by dx of dy by dt. So minus 1 by x square dy plus 1 by x, again chain rule, apply chain rule for this. So dy by dt of dy by dt into dt by dx. So again dt by dx is 1 by x. So this becomes d square y by dt square, that is d square y. So d square y by dx square is equal to 1 by x square d square y minus dy. So send this x square to the other side. So x square d square y by dx square will be equal to, you take d common, d into d minus y. So here variable coefficient x square is there. On the right hand side we don't have variable coefficient. So similarly you can find x cube d cube y by dx cube is equal to d minus 1, d into d minus 1 and d minus 2 y. Similarly x power n dn y by dt, dx power n is d into d minus 1 into d minus 2 into so far d minus n minus 1 y. So these are important for results for us, and we straight away apply these results in solving problems. Say for example, consider a Cauchy equation of the form x square y double dash minus xy dash plus y is equal to log x. It's clearly it's a variable coefficient. So observe the terms very clearly, whether it is a Cauchy equation or not. Variable coefficients means here the coefficient of y double dash must be x square. Coefficient of y dash is x. Coefficient of y is 1. Okay. So this is in the Cauchy's form. So let x is equal to e power t. Then t is equal to log x. Then x into y dash. We have seen this formula. No? X into y dash becomes dy. So x square y double dash is d minus 1 into y. Substitute these things in the given equation. X square y double dash is d into d minus y minus xy dash is minus dy plus y is equal to log x becomes x is equal to e power t. What is log x? T. So the independent, where is the change now? Y is same thing, but independent variable is changed from x to t, isn't it? Now the independent variable x is now expressed in terms of t. That's what we did, this trick we played. So this d square, if you simplify this, if we take common y here, d square minus d minus 2d plus 1 is equal to t. So it is now a linear differential equation with constant coefficients. We know how to deal this. First auxiliary equation. This is d minus 1 whole square or m minus 1 whole square is equal to 0. So m is equal to plus or minus 1. Okay. So y complementary function becomes, because repeated roots, c1 plus c2t. This is where 99.9999 students are committing mistakes. What is that? We are used to write c1 plus c2x into e power x, and you write similarly here. But it's not so. X is independent variable here. Now this is the problem. So what is independent variable? T. Y. At the end again you have to substitute t is equal to e power t is equal to log x. Okay. If you don't write t x here, at the end you will forget. You will overlook that and leave it, and everything will be in terms of x. So the answer is not correct. For example, here if you don't write t, what happens? Complementary function c1 plus c2x e power x. Is it correct? No. But if you substitute t again, your complementary function becomes c1 plus c2 log x into x. So a lot of change is there. Okay. So be very careful when you apply this Cauchy's method here. The new independent variable is t. So the function here should be a function of t. So now particular integral becomes 1 by d square minus 2d plus 1 from this operate on t. We know that because whenever you have polynomial functions, we expand in the increasing powers of d. So 1 plus d into d minus 2 whole power minus 1 t. So second degree terms, second degree polynomial we need not consider because derivative of that derivative t becomes 0. So 1 by d minus 2 into t is equal to 0. If we operate this, t minus d square of t is 0 plus 2d of t is 2. So complete function is, general solution is c1 plus c2t e power t, complementary function, plus particular integral is t plus 2. Now substitute t is equal to log x. So that means c1 plus c2 log x, e power t is x, t is log x plus 2. This is your complete solution. Try another problem. Here it is x square y double dash plus xy dash plus y. So again it's in the form because y double dash coefficient is x square, y dash coefficient is x, so on and so forth. It is almost, it is exactly in the Cauchy's form. So what we do, we put x is equal to e power t and then log x becomes t. So with the substitution, what we are having, x into y dash is equal to dy and x square y double dash is d into d minus 1 y. These are the two things that we get as a consequence of this. So put these two things here in this. So x square y double dash becomes d into d minus y and x y dash becomes dy plus y is equal to log x is t sin t. Okay. So simplify this. So d square minus d plus d. So cancel and then y. So d square plus 1y is equal to t sin t. So auxiliary equation, m square plus 1 is equal to 0. So your roots are m is equal to plus or minus y. So y complementary function is c1 cos t plus c2 sin t. So particular integral is 1 by d square plus 1 t sin t. So whenever you have multiplication of t into v of t, we have done. Another important technique is, we know that e power, this is very important technique for many types of problems. Observe this, understand this method. Okay, sin t, we know that e power it is equal to cos t plus I sin t. Okay, it's always easy to deal with exponential functions than any other function for that matter. So how we write this sin t as is the imaginary part of e power it. imaginary part of e power it. So sin t, how I write is 1 by d square plus 1 t into imaginary part of e power it. Okay. So this is an imaginary part of this imaginary, because this is all real part. Even if you bring out this imaginary part, nothing happens. So I p means imaginary part of 1 by d square plus 1 t e power it. So this is imaginary part of e power it. Shifting property we have now. You bring out this e power it, then 1 by d plus I whole square. What happens? E power ax into vx. What is 1 by f of d e power ax into vx? E power ax into 1 by f of t plus a on vx. That's what we are doing. Bring out this e power it, then 1 by d plus I whole square plus 1 operated on t. That is equal to imaginary part of e power it 1 by d plus I whole square is d square plus 2id plus I square. Plus I square means that becomes minus 1 and plus 1 cancel. So 1 by d square plus 2id operated on t. So that is imaginary part of e power it into 1 by d if you take 1 by 2id if you take common 1 plus 1 by d plus 2i. If you take 2id, this becomes 1, this becomes d by 2i operated on t. So your imaginary part of 1 by 2a take it out, e power it 1 by derivative of this is 1 plus d by 2i inverse. So that becomes 1 minus d by 2i d square by minus 4. Beyond that we don't consider, because d cube term of d cube of t becomes 0. So imaginary part of 1 by 2i e power it 1 by d, this is t minus d by d of t is 1 by 2i. So this term is becomes 0. So again 1 by d is there. Again integrate this. 1 by d means integration. So imaginary part of 1 by 2i e power it, integral of t is t square by 2, integral of 1 is t. So now use again e power it, expand e power it, cos t plus I sin t, t square I by 4i square. If you take this 2i inside, cos t plus I sin t square by 4i square, multiply with I, numerator and denominator, I square, it becomes I square, plus minus t by 2i into 2i is minus 4. So minus of minus becomes plus 4. So imaginary part of this. Now multiply this, multiply and see the imaginary part. Cos t is a real part into the imaginary part here. That is minus t square by 4. So minus t square by 4 cos t. And the second function is imaginary part is sin t. This imaginary part into this real part, sin t into t by 4. So this is your yp now, because we have compared imaginary parts both sides. This is what we get. So this is your yp. So y is equal to c1 cos t plus c2 sin t minus t square by 4 cos t plus t by 4 sin t. Problem is not over. Why? We started problem in terms of x. We introduce the variable, new variable t, by assuming x is equal to e power t. So again we go back to terms of x. So what is t? Log x. So c1 cos log x plus c2 sin log x minus log x whole square by 4 cos of log x plus log x by 4 sin of log x. So this is your solution. Y. Another is a equation with linear equation with variable coefficients, and which can be converted into linear equation with constant coefficient is Legendre's equation. The first one is Cauchy's equation, and this is Legendre's equation. In theoretical aspect, they can ask you what is the function which transforms Legendre's equation into linear differential equation with constant coefficient. The function is, substitution is ax plus b is equal to e power t, or t is equal to log ax plus b. That is the function which transforms the Legendre's equation into linear differential equation with constant coefficient. See, when we discuss a problem in the examination, every part of the solution can be asked as a question. See, now how many things I can ask, what is the, I'll tell you how many questions I can ask. What is the function which transforms Lagrange's equation into linear differential equation with constant coefficient? Then A, B, C, D, 4 options for 4 different functions. We have to select the suitable function. So that is Ax plus B is equal to e power t. E may be second option, or it can be given as x is equal to e power t minus b by a. Same thing. Or t is equal to log ax plus b. So different options may be there. That's one question. Second, when in the process of converting Legendre's equation into linear differential equation with constant coefficient x square d square by dt square, t square d square by dt square, d into d minus 1 of I, where d is equal to d by dt, and some other option. That is one question. Another bit short answer question. Okay. Or else a problem is given like this: 1 plus x whole square y double dash plus 1 plus x y dash plus y is equal to 0. If you convert this into linear differential equation with constant coefficient, what is the resulting equation? What is the resulting equation? So, if d is equal to d by dt, the resulting equation is 1 plus x whole square y double dash is equal to d into d minus y, 1 plus x y dash is equal to dy. You substitute these two things here, then you get the new equation as d square plus 1. That's what we get. So each of this is a bit for you. So don't look at the problems as a very big problems. We don't get them in the equation. From this, I can ask minimum 5 to 7 questions, 7 multiple choice questions from the same problem. It can be. So if you understand the procedure, then it will be able to answer any of the 5 or 6 questions that might be asked in the examination. So be like that, prepare like that. What is happening while doing the problem, you understand very clearly, because each one of those procedures can be a question. Okay, so with this, when ax plus b is equal to e power t, t becomes log ax plus b. So similar to the earlier case only we have x, but here ax plus b. So ax plus b dy by dx becomes a into dv, where d is d by dt. Similarly, ax plus b whole square d square y by dx square becomes a square d into d minus 1y, whereas in Cauchy's equations we don't have a squares here. Don't forget that. Note it. A also here. A square d into d minus 1y, because coefficient of x is a, that a comes here. Okay. Now you substitute this here. In this equation becomes a linear differential equation with constant coefficients. So solve the problem. 1 plus x whole square y double dash plus 1 plus x y dash plus y is equal to 2 sin log 1 plus x. So as here ax plus b is equal to e power t. So 1 plus x is equal to e power t. T is equal to log 1 plus x. So you need not prove this straight away. You can use this result here. So ax plus b into dy by dx is equal to dy, and 1 plus x dy by dx is equal to dy by dt, and 1 plus x whole square d square by dx square is equal to d into d minus 1 and y, where capital D is d by dt. You substitute these things in the given differential equation here. So this becomes d into d minus 1 plus d plus 1 y is equal to 2 sin log 1 plus x is d. So d square minus d plus 1. So d square plus 1 operate on 2 sin t. So complementary function m square plus 1 is equal to 0 is auxiliary equation. So m is equal to plus or minus I are the roots. So your complementary function becomes c1 cos t plus c1 sin t. Mind you, the independent variable is t, not x. So yc is c1 cos t plus c2 sin t. So yp is 1 by d square plus 1 operate on 2 sin t. So take So here what happens? D square, and here a is 1. So replace d square by minus 1. So this becomes 1 by minus 1 plus 1 becomes 0. F of minus a square becomes 0. Whenever f of minus a square becomes 0, 1 by f of d square sin t is t into 1 by f dash d square sin t. So that becomes 2 comes out, t also comes out, 1 by f dash d square. This is f dash d square, f d square, f dash is derivative of d square is 2d sin t. So 2 gets cancelled, t into 1 by d sin t. 1 by d is integral, so integral of sin t is minus cos t. So the solution is y is equal to c1 cos t plus c2 sin t minus t cos t, where t is equal to log 1 plus x. So substitute this, c is equal to 1 log 1 plus x. So c1 cos log 1 plus x, c2 sin log 1 plus x minus log 1 plus x into cos log 1 plus x is our solution. And that problem, 2x minus 1 whole square y double dash plus 2x minus y into y dash minus 2y is equal to 8x square minus 2x plus 3. So again 2x minus 1 is equal to e power t, or t is equal to log 2x minus 1, or x is equal to e power t. In the multiple answer questions, the right answer may be any of these things. 2x minus 1 is equal to e power t. T is equal to log 2x minus 1, or x is equal to e power t plus 1 by 2. Okay. So what happens is 2x minus 1 into y dash is dy into 2. Quotient of x is to that 2 comes here. Similarly, 2x minus 1 whole square y double dash is 4 into d minus 1 operated on y, where capital D is d by dt. So if you put these things in the equation, 4d into d minus 1 plus this is 2d minus 2y, that is equal to on the right hand side x square. Okay, we simplify this, 4d square minus 2d minus 2 is equal to 2 e power 2t plus 3 et power 3 e power t plus 4. I mean, you have substitute these things here. X square is e power t plus 1 by 2. So x square becomes e power 2t plus 1 by 1 plus 2et by 4, and then minus 2x is e power t plus 1 plus 3. So this is what we get, 4d square minus 4d plus 2, that is minus 2d minus 2 on y. So complementary function for this is auxiliary equation, 2m square minus m minus 1 is equal to 0. The roots are m is equal to 1 and minus 1 by 2. So c1 e power t plus c2 e power minus t by 2 is the complementary function for the reduced integral equation. Again, partial integral is 1 by 2d square minus d minus 1. Operate on this function, 2 e power 2t plus 3 e power t plus 4. And this is 4. Okay, right. So, because exponential function straight away can substitute this here, d square is 4, 2 into 4, 8, minus 2, 6, minus 1, 5. Coming to this e power t, 3 by 2 into e power t, a is 1, we put 1 here, 2 into 1, minus 1, minus 1 becomes 0. So in that case what we do, t into 1 by f dash t, operate on e power t. What is f dash d? 4d minus 1. 1 by 4d minus 1. A is 1. Substitute here, 1 by 4d minus 1 at d is equal to 1. 4 minus 1, 3. T e power t by 3. These things we have done earlier. I think I have not explained it clearly at this point because we have done all these problems earlier. So 3 by 2 into t e power t. The last one, when we have constant term. See, why I have written like this is, when you have constant term, generally is we have to expand this in the increasing powers of d and then apply it. Need not do it. The constant is 2 into e power 0 t, because e power 0 is 1. Okay. So when the advantage by writing like this is, you can apply the formula of e power ax. Straight away you can substitute 0 here. That's the advantage. So when 1 by d square 2d square minus d minus 1 operator on e power 0 t, substitute d here, 0 here, then what if it was minus 1. So that means you get the answer simply. So the y becomes e1 e power t plus e2 e power minus t by 2 plus e power 2t by 5 minus t e power t by 2 minus 2, and then put log t is equal to log 2x minus 1, we get the solution. So with this we conclude the ordinary differential equations. Before going to we will discuss some more problems, somewhat for practice problems. So here consider d power 4 by dx power 4 minus d cube y by dx cube minus 9 d square y by dx square minus 11 dy by dx minus 4y is equal to 0. What is a complementary function? Because you have only complementary function, you don't have particular integral for this problem. Why? Because we have a 0 on the right hand side. When we have 0 on the right hand side, particular integral becomes 1 by f of d on qx. Q is 0, so it becomes anyhow 0. So for homogeneous equations, we don't get particular integral. Don't worry about that. Solution means only complementary functions. So the other equation becomes the d power 4 minus d cube minus 9d square minus 11d minus 4 is equal to 0. Or else this is d plus 1 whole cube to d minus 4, m plus 1 whole cube minus m minus 4 is equal to 0. So the roots are 4 minus 1 minus 1 minus 1. The minus 1 comes 3 times repeated root. So corresponding to this root m is equal to 4, we get c1 e power 4x, and corresponding to the repeated root as said c2 plus c3x plus c4x square e power minus x. How many times we get corresponding to the repeated roots? How many times the root is repeated? Those many times, that many times we get here. How many times? 1, 2, 3, 3 times is repeated, so we get 3 terms here corresponding to minus m is equal to minus 1. So your complementary solution is c1 e power 4x plus c2 plus c3x plus c4x square e power minus x, and c1, c2, c3, c4 are arbitrary constants. When we solve d cube minus 6d square plus 11d minus 6 on y is equal to e power minus 2x plus e power minus 3x. So the auxiliary equation is m cube minus 6m square plus 11m minus 6 is equal to 0. The roots of which are d minus 1, d minus 1, d minus 2 and d minus 3. The roots are 1, 2, 3. So a complementary function becomes c1 e power x, c2 e power 2x and c3 e power 3x. Corresponding to then particular integral. What happens to the particular integral? 1 by f of d, that is 1 by d cube minus 6d square plus 11d minus 6 is equal operated on e power minus 2x plus e power minus 3x. So when operated on e power ax, it's not a big deal. Simply put that a in the equation. Here minus 2, that is minus 2 here. Substitute that minus 2 make f of d. So d cube is minus 2 whole cube minus 6 into minus 2 square plus 11 into minus 2 minus 6, and here also substitute this a is equal to minus 3 in this equation. Minus 3 whole cube minus 6 into minus 3 square plus 11 into minus 3 minus 6. So this becomes your particular integral. The complete solution is c1x e power x plus c2 e power 2x plus c3 e power 3x plus this is the particular integral. Next problem, find the particular integral of d cube plus 1 operated on sine 2x plus 3. So I asked only particular integral, no complementary function. It's not asked. So only particular integral 1 by d cube plus 1 sine 2x plus 1. So d cube is d into d square. Whenever we have d square term, substitute minus a square. So this is d into d square. So d square is replaced by minus a square, that is minus 4. So what happens is d into d square minus 4 becomes 1 minus 4d sine 2x plus 3. What I said, whenever d is remaining still in the denominator, then multiply and divide by 1 plus 4d, 1 plus 4d by 1 minus 4d into 1 plus 4d. So this is 1 minus 16d square. The numerator is 1 plus 4d. 1 plus 4d operated on sin 2x plus 3. 1 into sin 2x plus 3 plus 4 into d of sin 2x plus 3 means derivative of sin 2x plus 3. So that becomes 1 into sin 2x plus 3. 4 into derivative of sin 2x plus 3 is cos 2x plus 3 into 2. So that 8 cos 2x plus 3, that is our denominator. Coming to the numerator, coming to the denominator, what happens? Replace d square by minus a square, minus 4. So 1 minus 16 into minus 4. Numerator 1 plus 4d operator sin 2x plus 3. As I explained, this becomes sin 2x plus 3 plus 4d sin 2x plus 3. So that means sin 2x plus 3 derivative 8 cos 2x 3 by denominator 65. This is how we get the particular integral here. The next problem is find the particular integral of d square plus 4 cos x is equal to cos 2x. When you put d square is equal to minus 4, I am asking only particular integral, I am not working about complementary function. For each of the problems, you can calculate the complementary function also for practice. So m square plus, also the equation is m square plus 4 is equal to 0. So m is equal to plus or minus 2i for complementary imaginary parts only. So complementary function is c1 cos 2x plus c2 sin 2x. So particular integral is 1 by d square plus 4 cos 2x. So replace d square by minus a square. Minus a square is here is because a is 2, minus a square is minus 4. Substitute 1 by 0. So this is the failure case. In that case, what I said, x into 1 by f dash d. 1 by f dash is 2d cos 2x. So x by 2, 1 by d means integral of cos 2x. So x by 2 into integral of cos 2x is sin 2x by 2. So that becomes x by 4 sin 2x. So next problem is d square plus 5d plus 4y is equal to x square plus 7x plus 9. See, I have corrected one or two problems on each of these models. One is exponential function, one is trigonometric function, one is polynomial function, one is miscellaneous of all these functions. So exponential, sin x, trigonometric, polynomial, and then product of the functions. One from each case I have taken from books and books. So particular integral of d square plus 5d plus 4 on y is x square plus 7. This is polynomial. Okay. 1 by f of d, x square plus 7x plus 9. So when we have something like the polynomial functions x power k, what we do? We express this 1 by f of d in the increasing powers of d. So I take 4 common here. That becomes 1 plus d square plus 5d by 4. I expand this. It becomes whole inverse like this. 1 plus 5d by 4 plus d square by 4 whole inverse. Operated on x square plus 7x plus 9. So if we consider this 1 plus f phi of d whole inverse, it is 1 by 4, 1 minus 5d by d square by 4 plus 5, because 1 plus something in whole inverse is we get positive and negative terms alternatively. So this is negative term, this is 5d by 4 plus d square by 4 whole square. You need not go beyond this because highest degree polynomial is x square. When you operate d square with x square, you get d. D cube becomes 0. We need not consider. So what are the terms that we get is 1 minus 5d by 4 minus d square by 4. Here is 5d square by 24 because d square of x square is there. So 25 d square by 16 is possible. Then 2ab term where d into d cube not necessary. D power 4 not necessary. So on and so forth. So if you apply this, this is x square plus 7x plus 9 minus 5 by 4 d of x square plus 7x plus 9 is plus 25 by 16 into d square of this thing. So x square plus 7x plus 9 minus 5 by 4, d of x square is 2x, d of 7x is 7, d of 9 is 0. 21 by 16, d square x square is 2, d square 7x is 0, need not consider. So this is your answer. Find solution of d plus 2 into d minus 1 whole square y is equal to e power minus 2x plus 2 sin hx. 2 sin hx. See, we have not done this thing earlier. Sin h hyperbolic functions, right? This is an important good example for us how to deal with this. So the roots are clearly d is equal to minus 2 and 1 repeated root. So corresponding to the root minus 2, the complementary function becomes c1 e power minus 2x, corresponding to the repeated root c1 c2 plus c3x e power x. So particular integral is 1 by d plus 2 d minus 1 whole square e power minus 2x plus 2 sin hx. So 2 sin hx you can write as sin hx as e power x minus x by 2, or 2 sin hx is e power x plus e power minus x. So very finally, very nicely we have converted this into exponential functions. So 1 by d plus 2, 1 by d minus 1 whole square e power minus 2x. First consider this function. So all the terms are not done. Here you go. At least one term is there. 1 by d plus 2, 1 plus d minus 1 square e power minus 2x. So if you put d is equal to minus 2 here, minus 2 minus 1 whole square e power minus 2x. That becomes 1 by 9, 1 by d plus 2 e power minus 2x. If you put d is equal to minus 2, this becomes 0. So x into f, 1 by f dash d, 1 e power minus 2. The other terms you have to find. You have to put d is equal to 1, becomes 0. E power minus 1, so you have to calculate these two functions. In this, only the first function is calculated. D square plus 1y is equal to sin x sin 2x plus e power x x square. Combination of miscellaneous functions. Combinations are one or two functions. Auxiliary equation is m square plus 1 is equal to 0. M is equal to plus or minus I. So y is even cos x plus c2 sin x. So particular integral is 1 by d square plus 1 operated on sin x sin 2x plus e power x x square. Sin 2x we can write it as cos x minus cos 3x by 2. Trigonometric relations. Sin x to sin 2x is cos x minus cos 3x by 2. So 1 by d square plus 1 cos x minus cos 3x by 2. For the first function we'll see first. Okay. This is 1 by 2 d square plus 1 cos x minus 1 by d square plus 1 cos 3x. So minus 1 d square is equal to minus 1 becomes 0. So 1 by 2 x sin x by, why? Because x into 1 by f dash d, 1 by f dash d is 2d on cos x. So x by 2 into, okay, 1 by d of cos x is sin x. Right, this is how we get. Plus d square is minus 9, so this becomes minus 9 plus 1 is 8. So this, the first term is over. Okay, coming to e power x into x square. Whenever e power x into x square, e power x acts as a shift operator. So bring out this e power x first. Okay, then e power x into 1 by d plus 1 whole square plus 1 x square. So this e power x into d square plus 2d plus 1 plus 1 2d plus 2. So you expand this in increasing powers of f 2 and increasing powers of d. For that, take 2 common. Then 1 by 2 into d 1 plus d square plus 2d by 2 operate on x square. This is what we get. This is 1 minus d square plus 2d by 2 plus d square plus 2d by 2 whole square, so on and so forth, operate on x square. So the first step is x square, d square plus 2d by 2 on x square, d square plus 2d whole square by 2 on x square. So need not consider these things if up to this term is enough. So this is what the solution is. Next is particular integral of d square minus 4d plus 3 on y is equal to e power x cos 2x. So these problems you can do under 4 or 5 problems. Why? Because we want to go to quickly we'll go through the problems, and we have to deal with gate problems also. So d square by dx square, is this over? No? Yes. Let us see this problem because we have some conditions are given here. Better we go to this. D square by dx square plus 4 dy by dx plus 5y is equal to minus 2 cos hx. Again, hyperbolic function here that can be converted into exponential functions. I am interested in this. Sometimes the conditions will be given to you. Y of 0, y dash 0. These conditions are given. In the complementary function, we have arbitrary constants. For example, this becomes auxiliary equation is m square plus 4m plus 5 is equal to 0. The roots are minus 2 plus or minus I. So the complementary function will be y is equal to e power minus 2x c1 cos alpha x plus c2 sin. That means alpha is minus 2, beta is 1. So e power minus 2x to c1 cos beta x plus c2 sin beta x. So in the general solution of any differential equation, we are having this arbitrary constant. We have seen this arbitrary constant throughout. Okay. Sometimes the differential equations are associated with some conditions like y of 0 is 0, y dash 0 is 0, so on and so forth. So whenever we have them such terms, we have to, using these conditions, we have to eliminate C1 and C2. And then we have to give the answer. That is the purpose of giving these conditions. Let us see what happens. So complementary function e power minus 2x c1 cos x plus c2 sin x. The particular integral is 1 by d square plus 4d plus 5 minus 2 cos hx. So that is minus 2 cos x e power x plus e power minus x. So minus 1 by 4d d square plus 4d plus 5 operate on e power x plus 1 by d square plus 4d plus 5 operate on e power minus x. So substitute this quotient 1 here, minus 1 by 1 plus 4 into 1 plus 5, that is 10. Minus 1 here, minus 1 square plus 1, minus 4 minus 3 plus 5 is 2. This is what we get. So our complete solution is complementary function plus particular integral. Complementary function is e power minus 2x c1 cos x plus c2 sin x, and the particular integral is minus 1 by 10 e power x plus 5 e power minus x. Now use these conditions. Y at 0 is 0. So when you put x is equal to 0 here, y becomes 0. So e power 0 is 1. C1 cos 0 is C1. Sin 0 is 0. So what we have here? C1 is remaining here. This term is 0. E power 0 is 0. E power 0 is 1. So C1 into, so C1 minus 1 by 10 e power 0 1 e power 0 1, that means 5, 5 plus 1 6 minus 6 by 10. So C1 becomes 3 by 5. Okay. What about C2? C2 we have not calculated. Now we put C1 here in this. So solution becomes e power minus 2x C1, that is 3 by 5 cos x plus C2 sin x minus 1 by 10 e power x 5 e power minus x. So then put y dash. No, I think we won't get it here. Okay. We use the second condition. What is second condition? Y dash 0 is 1. So again, if differentiate this y dash and put x is equal to 0, you will get C2. That is missing here somehow. So d square plus 2d minus 3 operate on x square e power minus 3x. X square e power minus 3x. So I am considering different types of combinations of these functions as examples. So d square plus 2d minus 3 is auxiliary equation m square plus 2m minus 3, m minus 1 into m plus 3 is equal to 0. The roots of the auxiliary equations are m is equal to 1 and m is equal to minus 3. So the complementary function is c1 e power x plus c2 e power minus 3x. So particular integral is 1 by d square plus 2d minus 3 operate on x square e power minus 3x. So e power minus 3x is always operates as a shift operator, as I said, d minus 3 whole square plus 2 into d minus 3 minus 3. operated on x square. So e power minus, if you expand this, d square minus 6d plus 9, 2d minus 6. So if you simplify this, this is what we get, d square minus 4d operated on x square, e power minus 3x minus 1 by 4, because polynomial function I want increasing powers of this. So minus 4d, if I take common, 1 minus d square by 4d operated on x square. This is d by 4. So minus 1 by 4d, 1 plus d by 4, d square by 16, so on and so forth. So this is what we get, minus 1 by 4 x square, and then integrate, we get a solution like this. Then we have a still lengthier function, sin x sin 2x plus e power x square, complementary function, leave it. Then sin x sin 2x is cos x minus cos 3x by 2. Then e power x square, e power, then complete the problem with sin x and sin 2x, e power x into x square, e power x acts as shifting function. Then this is what happens. Then operate on x square. This is solution for this. So till now we have done 65 to 70 problems on ordinary differential equations till now. And now what next is, in our schedule today, before going to more problems on ODE, old questions. Do one thing. We have some problems, model questions, another 30-40 questions I have collected. Tomorrow I will discuss gate problems, and today we will go through some more problems. Another 40 problems I have, around 40 problems I have collected for you for practice, and just I will go on clicking the problem each one, and you can practice them. Find the general solution of d square plus 2d plus 2y is equal to, because right hand side is 0, you have only complementary function. Write the equation roots and then the complementary function. And what is the complementary function of d plus 1 into d minus 2 whole square y is equal to e power 3x? No need to find the complete solution, only complementary function. Roots are minus 1, 2, 2. So c1 plus c2x into e power minus 2x plus c3 e power minus x. The particular integral of 1 by d square plus a square cos ax. See, this is a failure case. When you put d square is 1 by f of d cos ax, when you put d square is equal to minus a square, failure case. Then what happens? X by 2 sin ax. What happens? X into 1 by f dash d cos ax. That is the rule that we follow here. What is the particular integral of d cube y by dx cube plus y is equal to e power minus x. That means 1 by f of d, 1 by d cube plus 1 e power minus x. A is minus 1. If you substitute, denominator becomes 0. So x into 1 by f dash d e power minus x. So that rule you have to follow here. Find the particular integral of d square minus 5d plus 6y is equal to e power 2x. I think this is also failure case. When you put d is equal to 2 here, 4 plus 6, 10, minus 10, 0. Failure case. Again you have to find the particular integral. What is the particular integral of d plus 1 whole square y is equal to x? Then what we are doing? We are expressing this 1 by d plus 1 whole square in the increasing powers of x. 1 by d square plus d plus 1 sin x. A is 1. Replace d square by minus a square. So that means integral of sin x minus cos x. All these problems, we are thorough with the formula. You can do it orally. You people are asking me tricks. There are no tricks here. You have to go through the formula and theoretical concepts thoroughly. You have to recollect immediately. That comes out of practice. Yes, within 3 minutes I could complete 7 problems. That is because of the practice. Okay. So you have to be very thorough with the formula. So if you hear d square is equal to minus 1 plus 1 becomes 0. 1 by d of sin x. There is integral of sin x minus cos x. Evaluate 1 by d minus 1 e power x sin x. So e power x into v of x. E power x as shift operator. You bring out this e power x. Then a is 1. 1 by d plus 1 minus 1. 1 and minus 1 get cancelled. You will be left with 1 by d sin x minus cos x. So d square, 1 by d square plus 4 sin 2x. Again d square is equal to minus 4. Failure case. So minus x by 2 cos 2x. Find the complementary function of the equation d cube minus d minus y, d cube minus d into y is equal to x. The auxiliary equation is m cube minus m is equal to 0, or m into m square minus 1 is equal to 0, or m is equal to 0 and plus or minus 1 are the roots. So complementary function is c1 plus c2 e power x plus c3 e power minus x. Find the complementary function of d square plus 4d plus 5 is equal to 30. When the complementary function is asked, we need not worry about what is there on the right hand side. It is immaterial because complementary function is the solution of the homogeneous equation. So get the roots of this. Okay, you will get the complex roots here. Find the complementary function. What is the perpendicular of d minus 1 whole square by sine 2x? So 1 by d minus 1 whole square sine 2x. That means d square minus 2d plus 1. D square is minus 4. So you substitute d square is minus 4. So minus 4 minus 2d plus 1. That is minus 1 by minus 2d minus 3. So because d term is there, d is there in the denominator, to eliminate that, multiply and divide by similar function with power. Okay, you will get that. Evaluate d 1 by d minus 1 x square. Write this 1 by this, write minus 1 by 1 minus d. So this is increasing powers of d, then expand it. If f of x is given, what is 1 by d minus a? Yes, this is the first integral we have written. Particular integral 1 by d minus a, 1 by d minus a into qx is e power ax integral e power ax into qx. So qx is e power ax here. So e power ax integral e power ax into e power minus ax, that is x into e power ax. Direct question. This is from the theory. Direct question from theory. See, for all these things you can write some alternatives A, B, C, D. So if all these questions are nothing but multiple choice questions, you can write some options and write the correct answer. Now, next one is, what is complementary function? It is not a essay question. Complementary function need not. See, this also can be expressed as a multiple choice question. What complementary function is? The solution of the homogeneous equation, solution of the non-homogeneous equation. It is solution of the nonlinear equation. It is solution of Bernoulli's equation. What is the option? Complementary function is the solution of the linear differential equation with constants coefficients. Wherever you find the option, that is the right answer. Next one is, define particular integral of a differential equation. Then particular integral of a differential equation is the solution of the homogeneous equation, the solution of the non-homogeneous linear differential equation with constant coefficients. Is a solution of nonlinear equation, solution of homogeneous equation. Different options. Right? Cauchy's differential equations. What is the which one of the following equations is a Cauchy differential equation? One is dv by dx plus, first option is dv by dx plus px y is equal to qx, x square y double dash plus xy dash plus y is equal to some q of x, 1 plus x whole square y double dash plus 1 plus xy dash plus y is equal to 0. You can have so many options. That's also a question on multiple choice questions. I think you have to remember this equation very well. What is the substitution used to convert a Cauchy differential equation to linear form? Substitution you should know. X is equal to e power t. Next, are the functions sin x and x sin x linearly independent? What is the testing condition for linear independence of functions? Jacobian. U and V are two functions of x and y. Jacobian of uv with respect to x is dou u by dou x, dou u by dou x, dou dash dou u by du by dx, u v u dash v dash. Wronskian, we have done Wronskian, no? Wronskian, what is Wronskian? y1, y2, y1 dash, y2. So modulus of determinant of sin x, x sin x, and then derivative of sin x, derivative of x sin x. Find is that equal to 0, not equal to 0. If it is 0, they are dependent. Not equal to 0, they are independent. If y and z are independent solutions of y double dash plus ay dash plus by is equal to 0, a and b are constants, then express any solution of the given in terms of y and z. There is some mistake here in this problem. There is some problem here because y and z cannot be independent. There is some problem here. Okay. So leave it. Let's delete this. This is a mistake in this. Solve 4d square minus 4d plus 1y is equal to 100. So complementary function plus particular integral. While finding the particular integral 1 by f of d on 100. When you have constant, what we are doing, what I told, you need not express the denominator as increasing powers of d. Simply this 100 or 1 lakh, even if it is there, don't worry. This 100 into e power 0t. When you have that 1 by f of d e power operate on e power g, put that 0 in this. So particular integral by looking at this 100 into e power 0x by this f of d. Excuse me. So next one is d cube minus 6d square plus 11d minus 6 y is equal to e power minus 2x plus e power minus 3x. So d cube. So we have done problems like this. First, find the complementary function 1 by f of d e power minus 2x plus e power minus 3x. Okay. So similarly, d cube minus 4d plus 3 y is equal to e power 2x. Substitute 2 here for the particular integral. E power minus 4x. Same thing. Complementary function plus particular integral. When finding the particular integral, a is minus 4. So if you substitute here, d square 16 plus 16, that is no problem. So d square plus 1 y is equal to sin x y into x plus e power x square. Sin x sin 2x we have to write in terms of cos x minus cos 3x. Excuse me. Hello. ఒక్క 10 నిమిషాలు మాట్లాడతాను నేను మీకు క్లాస్ లో ఉన్నాను. e power x square. So d square plus 3d plus 2 on y is equal to sin 3x. Similar problems. So sin 3x d square for the particular integral, if you replace d square by minus 9, so they become 3d minus 7. 1 by 3d minus 7 operate on sin 3x. So multiply and divide with 3d plus 7. So 3d plus 7 by 3d minus 7. And then replace d square by minus 9. So that's what we get here. And then d square minus 4d plus 3 on y is equal to cos 2x. So this is also similar case of finding the complementary function for a particular integral. Replace d square by minus 4. So minus 4d minus 1. Again, denominator contains a term d. So again, multiply and divide with some d terms here. You get the required things. So almost all the problems we have discussed, and one problem in variation of parameters we have done this also. Like this, to practice all the problems, as I said, I have demonstrated also earlier, yesterday and today also. Each problem can be divided into small bits. Each step that we do in each problem can be asked as a separate problem. Say for example, in this problem, if you take this problem, here what is the complementary function? That's a problem. That's a bit. What is the particular integral of this thing only with e power 2x? Only with this or only with this? I think you have 3 different problems. If you solve these problems equivalent to solving 4 problems here in this. 4 problems here. And similarly, I explained you how Cauchy's and Legendre's equation, while discussing Cauchy's and Legendre's equation, each problem is equivalent to 4 or 5 problems. What is the substitution? What is the Legendre's equation? What is what is the function which converts Legendre's equation into linear differential equation? One problem. And then what is the substitution that is used to convert Legendre equation into constant equations? One thing. If in the process of conversion, what is x dy by dx in Cauchy's equation is equal to dy by dt. There is general form. What is x power n dn by dxn is equal to d into d minus 1 into d minus so on and so forth. No, general term is there. Like that. You can ask, there can be 4 or 5 questions from single problem. So if you do a problem that we have discussed, it is equivalent to doing 3 or 4 problems. So I have today, I think in ordinary differential equations we have done around 110 problems till now. Okay, in my PPT notebook preparation, that is 60 problems. This is 96 problems, and in my PPT playtime I have given you 11 more problems in this. Okay, 11 plus 36, 47 plus 60. Around 107 problems we have done differential equations. Okay, so thing is, you have to, after this class, we have to go through the concepts once again, do all the problems on your own. Definitely, any problem that comes in your GATE examination, you will be able to crack it. Somebody is asking how to crack the GATE, tell me the tips to crack the GATE. You don't, if you want to crack the GATE, you have to hit it hard, my dear friends. Hit it so hard that the gates will be cracked. But don't ask me to tell the tricks. They are not tricks. You have to hit it hard, that's all. So, in each of the subject, I am giving around 80 to 70 to 90 problems. Vector calculus, I have given 85 problems. Different equations set on 105 problems. You have to practice all the problems. If you practice all the problems, that is enough. Whatever problems we have done in these presentations, in these 8 days, they are enough for you to crack, to clear the mathematics question in GATE examination. Rest depends on you. You have to work hard. Okay. So I stop it here. Tomorrow we will discuss some more problems on differential equations. From the previous question papers. From the previous question, we have not done it till now. So the PPT is also ready with me for that. Okay. We'll deal with these previous question papers. Go to the questions on differential equations from previous question papers. We'll finish it off tomorrow, and then we'll take up partial differential equations tomorrow. So for today, it's over. Thank you.